Finally, we come to the maybe the most exciting and the practical part in today's session. The third part, how to do the analysis in a factorial survey experiment. So in this part, the case data I provided was come from my own research, where I want to test whether the features of an AI recommendation system will affect the citizens' compliance to the AI recommendations. So the testing hypotheses are when the AI system is more transparent, more responsive, and more useful, citizens are more willing to comply with AI recommendations. And also, I have a moderator here that the impacts of transparency, responsiveness, and usefulness on citizen compliance are likely to be weaker when citizens are exposed to more negative information about AI. So the key variables here are independent variables are transparency, responsiveness, and the usefulness of AI recommendations. And the dependent variable is citizen compliance. For those three factors, each factor categorized into two levels, the higher level and the lower level. And the moderator here is negativity bias and other variables, including the AI familiarity, gender, age, and educational level. So for the data, this is a panel test data collected from Credemo, and the now total number is 137. The analysis method including the ANOVA and OLS regression. For the analysis content, we will do a descriptive analysis first and then do the randomization and the manipulation check. And before the ANOVA analysis, we need to check whether the characteristics of our data are well fitted to the ANOVA test assumptions, like whether it's a random sampling, whether it fitted the normality, the homogeneity, or variances. And then if we pass the test assumptions, we can do the ANOVA analysis, and then finally we will do an OLS regression analysis to test the moderating effect. So for the descriptive analysis, we first need to report the demographic characteristic of the participants. So in the RStudio, we can first input our data. We need this library, read Excel to input our data from an Excel file. And for the first one, the descriptive statistics, there are many packages that can be used to do the descriptive analysis. Here we mainly mention two methods. The first one is use the basic function, like we need a seg package. We can elaborate first, and then we can use the command describe data. So here it give many you can give the number, mean value, standard deviation, median, and some other values of these key variables. And also we can define our own customized function, like we may don't need so many information and we only need the number, the mean value, and the standard deviation. So we can define we use the function command to define our own function first, and then we want to know how many males and how many females in our sample, and what are their educational conditions and what are their average age. So we can use the command by to know, like here we have 0 means male, we have 47 males and 19 females among the participants. And also for the education level, we have 4 participants hold the high school and below diploma, and 76 holds the bachelor's degree, 55 holds the master degree, and 2 hold the doctoral degree. And also we use the mean command to calculate the mean value of the age. So now we can see the average age is 28. So we can then we can use this information to report uh, our demographic information. Like here, we can show the demographic characteristics of participants based on these function commands. And then the next one, we need to know the overview of participants per treatment group and their average compliance level. So we also, similar to the former function, we will use the command. So the first is a variable we want to calculate, and the second one is a group variable. Like we want to calculate their compliance level based on their group. So we can use this function. Wrong. So we know each groups their total the participants in the number of participants in each group, the mean value of their compliance level, and the standard deviation of their compliance level. And also we can calculate the whole samples mean value of compliance level, and also the standard deviation of the whole compliance level. So based on this, we can we can report this table 2, the overview of participants per treatment group and the average compliance level. Here we can see the group 1 has the highest mean value of citizen compliance, and the group 8, the lower one, may have the lowest level of citizen compliance. And then for the randomization check, we use the cross-code test in the R Studio. Like first, we want to know the randomization check is used to test whether there are significant differences among the control variables between those different participants in each group. So we first will need to know we usually use the mean value to do this test. So we first need to know their average, use their mean value of each variable based on the group variable. So we use this function to know for the first one, the age, the mean value of age in each group. Like the group 1, where the average age is 30, the group 2, the average is 26. So based on this, then we need to do the differences between the subgroups. We use a cross-code test. The first one is our test variable, and the second one is our group variable. So we do the test. Then we can see that the p-value, the result shows that the p-value is larger than 0.1. Which means there are not significant differences among these demographic variables among the participants in different groups. So we can show this in our report that the randomization check of 8 groups, which means there are low statistically significant differences between the groups in terms of the age, gender, education, and the hair familiarity. So we can say that this passed the randomization check. Then for the manipulation check, we want to know whether whether participants in this survey experiment can perceive the different level of the transparency, the responsiveness, and the usefulness. So in the R Studio, we also similar to the randomization check, we first report the mean value of each group. So we can see here the perceived transparency in lower level transparency group is 4.09, and the perceived transparency in higher level transparency group is 4.73. And then we do a t-test because there are two groups. And then we can see for the transparency, there are significant differences between the lower transparency group and the higher transparency group, and also the responsiveness and the usefulness. So we can also report this in the table 4. Like we show that the participants in two levels or groups perceived significantly differently regarding the transparency, the responsiveness, and the usefulness of AI, which means the participants correctly perceived or reacted to the stimulus. So we can say now we pass the manipulation check. And then before the ANOVA analysis, we need to assessing the ANOVA test assumptions. We need to check several assumptions. The first one is the normality, whether data within each group should be normally distributed, and the homogeneity of variance means the variance of the data within each group should be equal, and the independence, the observations within each group should be independent. Because in the survey design, before the in the experiment process, we can ensure the independence of the participants. So we only need to check the normality and the homogeneity of the variance. So for normality test, we usually use the QQ plot to visually show the normal distribution of the observations. So we first need this car package. So we library the car package, and also we need to first construct a linear regression model for the testing. So the LM is a linear model function, and the dependent variable here is compliance, and the independent variables are transparency, responsiveness, and usefulness. The asterisks here means we want to test the main effects and the interaction effects among these three variables, and the data is the data frame. And the QQ-plot function here, the first is a model we constructed and simulated. True means we want to use the simulated data to test the normality, and the main means the title of this graph, and the labels false means we don't want to show the labels. Now we run this command, and now we can see here in this QQ plot, the observations are all in the normal distribution interval. So this means we pass the normality test. And the second one is the homogeneity of variance. We use the Bartlett test. Like the first one is the dependent variable, and the second one is the independent variable. So we test this. And we can see here the p-value is larger than 0.1, means there are no significant differences among the variances of these independent variables. But for the third one, the usefulness, it's lower than 0.05, but it's okay, as it's acceptable as the other two variables past the homogeneity of the variance. So now we back to our report. So we can see the observations of the dependent variable are at the 95% confidence interval, satisfying the assumption of normality, and also the variances of the 8 groups were not significantly different. So in conclusion, the collected data can be fitted well with an ANOVA model. For the conditions that these test assumptions are not very well fitted, you can consider a robust ANOVA analysis using WRS2 package. So this paper introduced in detail about how to use this package to do a robust ANOVA analysis. If you are interested in it, you can read this article. And then for the ANOVA analysis, we can show this in the R. So for the ANOVA analysis, we need to label this package because we want to add an additional calculation to calculate the partial eta squared, to which are used to measure the extent to which different factors can contribute to the change in the dependent variable. So we first library this package, and then for the ANOVA analysis, we will use this AOV command. The compliance is the dependent variable, and here the independent variables are transparency, responsiveness, and usefulness. These asterisks means that we want to test the main effects and the interaction effects of these key independent variables, and here we identified the data. So we run this command, and here we show the impact of the transparency, responsiveness, usefulness, and their interaction effects. And also we use partial eta squared. And this means the transparency contributes to 17% changes in the citizen compliance, responsiveness contributes to the 15%, and usefulness contributes to 4.4%. We can also use a graph to show the interaction effects. Like here, we may use these three packages. So we use this interaction to WT command. So here the compliance the dependent variable, and with the independent variable, the data, and the LTY means the 9 types. So here we have 2 types. And this R strip text means the size of the strip text. And outlier label false means we do not show the outlier labels. And the response lab expression means we want to labeling the dependent variable. And also the main means the title of the graph. And the CEX means the size of the title. So we can run this one. And here we can see these three are the main effects of the transparency, responsiveness, and the usefulness. And the others are the interaction effects between the two independent variables. Like this one is the interaction effects of responsiveness and transparency. We can show this in our report. Like first, the table 5, ANOVA analysis results of air transparency, responsiveness, and usefulness. Here we can see these three independent variables and the interaction effect of transparency and the responsiveness have significant impact on citizen compliance, with transparency contribute most to the citizen compliance, followed by responsiveness and usefulness. And also here we can show this graph to use this graph to show the interaction effects and the main effects. Then for the OS regression in the RStudio, we need this linear model to build our regression model. Like here, dependent variable is compliance. And here we change the asterisk to the plus, which means we only need this the main effects of these three independent variables. And we also added the gender, education, age, such these are the control variables. So this is the basic model. And then the next one is the moderating. We added based on the basic model, we added the moderator negative information bias and this impact on three independent variables. Like we added the interaction effect of like the transparency, negative information bias, responsiveness, usefulness, and also the control variables. So we run these two models to linear regression models, so we can get the results, show the p-value, t-value, standard error, and the coefficient, and also here the r-squared. So we can transform this to a table in our report, like this table 6, OLS regression results. Here we can see our independent variables have significant positive effect on citizen compliance. And also negative information bias has a moderating effect on the transparency. And these are all the analysis that we may need to do in a factorial survey experiment. And also these are the references for your to consider if you are interested in the survey experiments. I strongly recommended these two books. The first one is the Cambridge Handbook of Experimental Political Science, and the second one is the Experiments in Public Management Research, Challenges and Contributions. And these are what I want to share with you about the survey experiment. And if you have any other questions, please feel free to contact me. And that's all. Thank you.